Usually, when you think of female pelvic health, your mind just goes straight to estrogen, right? Like it's always the star of the show.
Oh, absolutely. Yeah, estrogen is basically the default assumption for everything in that space.
Right. But the success of the cutting-edge regenerative treatments we're looking at today actually relies on a pretty shocking paradox. I mean, the secret to how well these therapies work for you might actually be uh, your body's quote-unquote male hormones.
Yeah, and that completely upends how we typically look at the human body. I mean, we have this huge tendency to neatly gender our biology, right?
Ah,
Like estrogen is female, testosterone is male.
exactly.
But down at the cellular level, that division is just a total myth.
Which is exactly what we are exploring today on this deep dive. So welcome. We're looking at the biological collision happening inside treatments like the O-shot.
Right, getting into the real mechanics of it.
Yeah. And our mission today is specifically to figure out how a systemic lack of androgens, so, testosterone and its byproducts, fundamentally alters how your tissue responds to the massive collagen-building signal of platelet-rich plasma.
It's such a specific, crucial interaction.
It really is. And for this, we're pulling from a huge stack of sources.
Yeah.
We have clinical data on PRP therapies. We have genetic insights into the human androgen receptor from the NCBI gene database, and some truly fascinating specialized research on how sex hormones dictate wound healing.
Yeah, and you really have to synthesize all three of those fields to understand what is actually happening in the clinic. I mean, you can't just look at the injection itself. You have to look at the whole environment receiving it.
Exactly. So, well, let's start with that injection, the O-shot.
Let's do it.
So it's pitched as this quick 30-minute non-surgical fix for sexual wellness. You walk into a clinic, they do a standard blood draw from your arm, and then they take that vial and spin it down in a centrifuge.
Right. And the centrifuge is doing something very specific mechanically there. It's separating the components of your blood based purely on density.
Just literally spinning the heavy stuff to the bottom.
Exactly. So the heavy red blood cells sink down, and you're left with this golden layer of plasma at the top that is absolutely just packed with platelets.
Right. Platelet-rich plasma, the PRP.
Exactly.
So they draw that PRP into a syringe, and after applying a really strong local anesthetic cream so the whole process is comfortable for you, the practitioner injects it directly into the quote-unquote O spot.
Right, which is the vaginal and clitoral tissue.
Yeah. And the stated goal in the clinical sources is to support arousal, improve lubrication, and even treat mild urinary symptoms.
Which is quite the list of benefits.
I know. On a surface level, it sounds like a miracle cure, right? But let's get into the actual biological mechanism. When that concentrated plasma actually hits the tissue, what is physically happening down there?
Well, the physical trauma of the needle itself, combined with the chemical environment of the tissue, forces those injected platelets to undergo a process called degranulation.
Meaning they basically just burst open.
Yeah, pretty much. I mean, think of a platelet as like a microscopic water balloon.
Okay.
But instead of water, the balloon is packed with these little sacs called alpha granules. And when the platelet gets activated in the tissue, those sacs basically fuse with the cell's outer membrane and just dump their contents into the surrounding area.
Oh, wow. So it's just this massive immediate payload.
Exactly. It's a huge payload of highly bioactive growth factors. In fact, they release 7 different key growth factors.
Yeah, the sources actually list a whole alphabet soup of them, things like PDGF and VEGF. But there is one major player that seems to really drive this specific regenerative process, right?
Yes. TGF beta, or transformed growth factor beta.
Right, TGF beta.
It is the absolute star of the show for tissue regeneration. When that flood of growth factors soaks into the pelvic tissue, it's actively looking for specific targets. It's primarily communicating with your local stem cells and, crucially, your fibroblasts.
Fibroblasts, I saw these mentioned constantly in the literature. They're basically the architects of your connective tissue, right?
Yeah, that's a great way to put it. If you picture your pelvic floor and vaginal walls as this complex physical scaffold, the fibroblasts are the microscopic workers actively building and maintaining that structure.
So they're doing the heavy lifting?
Absolutely. They build what we call the extracellular matrix, or the ECM.
And they build that matrix out of collagen and elastin?
Precisely. They are the factories churning out the actual building blocks of your tissue.
So injecting this concentrated PRP is basically like, I don't know, a construction foreman arriving at a building site with a massive megaphone.
A megaphone. I like that.
Yeah, he's just blasting instructions at the worker cells, the fibroblasts yelling at them to rapidly start building new scaffolding, new collagen to repair the tissue.
Yeah, a very loud, very demanding foreman. The PRP is just this overwhelming, concentrated signal commanding robust tissue repair.
Right.
And because the signal is derived from your own blood, the body readily accepts the instructions without triggering any kind of allergic rejection. It's a beautifully elegant system.
Which sounds incredibly promising for anyone listening who's considered this.
Mhm.
But if the foreman is yelling at the cells to build collagen in female tissue, why do the clinical and genetic sources suddenly pivot so hard to endocrinology?
Well, that's the catch.
Right, like why on earth are we bringing testosterone into a conversation about vaginal rejuvenation?
Because a foreman with a megaphone is completely useless if the workers are wearing earplugs or, if the building materials on site are totally the wrong kind.
Yeah.
The loud signal from the PRP doesn't happen in a vacuum. It happens in a really complex cellular environment. And that environment is heavily, heavily dictated by hormones.
Okay, let's trace this back to the genetic blueprint from the NCBI sources then, because every human being has an androgen receptor gene.
Right, the AR gene. It's a 90 kilobase long gene that codes for a protein that basically acts as a steroid hormone-activated transcription factor.
Okay, let's translate that into something we can visualize. It sounds almost like a lock and key mechanism.
That is a perfect way to look at it.
Yeah.
So the androgen receptor is the lock, and it sits inside the cell. The key is a potent androgen, like DHT.
Which is dihydrotestosterone, right?
Exactly, a highly active metabolite of testosterone. So when that DHT key floats by and docks into the receptor physically changes its three-dimensional shape.
Oh, really? It actually changes shape.
Yeah, and then it travels. It moves deep into the cell's nucleus, binds directly to the DNA, and starts modulating gene expression.
Wow.
It literally turns specific cellular functions on or off.
And the crucial detail from the genetic sources is where these locks, these receptors, are actually located. I mean, we tend to assume they're only in muscle tissue, right?
Right.
Or male reproductive organs.
Which is entirely wrong. They are heavily expressed everywhere, especially in the macrophages and the fibroblasts of your skin and your deep connective fascia all over the body.
Which means your pelvic fibroblasts are constantly listening for androgen signals.
Exactly.
But women naturally have significantly lower levels of androgens than men. Which brings us to the wound healing research.
Yeah.
And I have to say, this is where my brain just completely stalled reading the sources.
Yes. The great paradox of androgens and tissue repair.
Right. Wait, let's unpack this for a second, because we usually associate testosterone with building things, right? It builds muscle mass, it builds physical strength.
Yeah, that's the common perception.
So why in the world does the data show that high androgens actually stop the body from fixing a wound and building collagen? Like, why would the body do that? It feels entirely backward.
It does feel contradictory, for sure. Until you look at how the human body manages a crisis from an evolutionary perspective.
Okay.
If you sustain a wound, the body's immediate reaction is basically panic. It triggers massive inflammation and aggressively rushes to patch the hole with collagen so you don't succumb to an infection.
Just slap a patch on it as fast as possible.
Exactly.
Yeah.
But rapid aggressive healing isn't necessarily functional healing.
Oh, I see.
Yeah. If that inflammatory and collagen-building response isn't tightly controlled, you don't get supple, healthy skin back. You end up with really dense, rigid, fibrotic scarring.
Which is bad.
Right. So in evolutionary terms, androgens maintain homeostasis. They keep the body from overreacting to trauma.
So how do they physically suppress that overreaction? What's the biochemical reason?
They do it by dampening the internal cellular chain reactions. When DHT binds to those fibroblast receptors we talked about, it actively suppresses that TGF-beta pathway.
The megaphone from the PRP.
Exactly. It specifically blocks an internal signaling chain called SMAD2 and 3 phosphorylation.
Okay, so think of it like kinking a garden hose.
Yes.
The water, meaning the command to build collagen, is trying to flow really heavily from that PRP signal, but the androgens kink the cellular hose and slow it down.
That's spot on. They're the biological brakes preventing runaway fibrosis. The studies actually show that in animal models, if you chemically block androgen receptors entirely at the site of a wound, healing speeds up dramatically.
No.
Yeah, the inflammation stays high, and the matrix deposition, the collagen, just goes through the roof.
Which brings us to the core mystery of this deep dive. What happens when you combine that massive PRP payload, which is the gas pedal, with a systemic androgen deficiency?
And that is the million-dollar question.
Because most women getting the O shot, particularly, menopausal women, are operating with very low androgens,
Hmm.
which is just their baseline, so the biological brakes are effectively gone.
Right. And to see the result of that collision, we look at this absolutely fascinating study on human fascial fibroblasts.
Yes, the Geraldo study.
Exactly. Researchers took deep connective tissue cells from both male and female donors. And remember, these cells all have androgen receptors.
Right, the locks are there.
Yes. So the researchers grew them in a lab and exposed them to different concentrations of DHT to see how they would rebuild their physical matrix.
And the concentration changed absolutely everything about how the cells behaved.
Completely night and day. When they bathed the fibroblasts in low female equivalent levels of DHT, we're talking around zero point 0.4 nanograms per milliliter, the cells just went into absolute overdrive.
Wow, zero point 0.4 nanograms.
Yeah, it's tiny. But they didn't just build more tissue. The fundamental structure of the tissue changed. They began producing a highly fibrotic matrix.
The data here is wild. I mean, at those low antigen levels, the cells didn't just build a little bit of stiff collagen. They surged their production of collagen type I to nearly 4.8% of the cell area.
A huge spike.
Yeah. While the flexible, youthful stuff, collagen type 3, absolutely plummeted to like 3.3%.
Yeah.
We really need to contrast those two because the type of collagen seems to be the difference between a successful regenerative treatment and a complete disaster.
It absolutely is. It is
Mhm.
the difference between building a structure out of stiff twine versus building it out of rubber bands.
Okay, so type I is the twine.
Right. Collagen type I is structurally rigid and strong. Your body relies on it for bone, for tendons, and for rigid scar tissue. It holds things very tightly together, but it has almost zero give.
And type 3 is the rubber band.
Yes. Collagen type 3 is the flexible, compliant, elastic scaffolding. It's what gives youthful skin its bounce, and it's what gives healthy vaginal tissue its stretch and physical resilience.
So basically, by having low androgens, the body automatically defaults to building stiff twine instead of flexible rubber bands.
Yes. Now look at what happened when those same researchers increased the DHT to male equivalent high doses.
Which was what, around 4 to 10 nanograms per milliliter?
It's exactly 4 to 10. At those higher concentrations, the total collagen content actually dropped. The extracellular matrix stayed perfectly balanced.
The brakes kicked in.
Exactly. The androgens applied the brakes, actively stopping the overproduction of that stiff type I collagen.
Okay, so answering our main mission question here, getting an O shot when you have an androgen deficiency is quite literally like pressing the gas pedal to the floor on a car that has no brakes.
That is a perfect visualization. The O-shot delivers that concentrated flood of TGF-beta. The megaphone is just screaming at the fibroblast to build.
Right.
But because the patient has a systemic lack of DHT, there is no kink in the cellular hose. There's no suppression of that TGF-beta and SMAD2 and 3 pathway. The internal chain reaction just runs completely wild.
So you get this massive rapid burst of regeneration from the PRP, but it is heavily, heavily skewed toward that stiff, rigid type I collagen.
Exactly. You are forcing the tissue to regenerate rapidly, but you are doing it in a hormonal environment that naturally favors fibrosis and stiffness over elasticity.
Which brings us to the real world. Why does this biochemical interaction actually matter to you, the listener, if you're considering these treatments?
Well, it changes everything about managing expectations.
Because the natural assumption would be that, an older postmenopausal patient with very low hormones just wouldn't respond well to a regenerative treatment.
Right, you'd think the cells are just tired and won't do anything,
Yeah, that they'd just have a weaker response to the PRP.
which is a very common, very dangerous misconception. The science shows her tissues aren't sluggish at all. They are actually hyper-responsive.
Just in the wrong way.
Right. The lack of androgens means her fibroblasts are primed to totally overreact to the PRP signal. But they overreact in a profibrotic way.
So she might spend thousands of dollars, go through this whole procedure, only to find that the PRP led to stiffer, more rigid tissue rather than the supple, elastic tissue she was hoping for.
Which completely defeats the entire purpose of the O-shot for sexual wellness.
Uh,
I mean, more stiffness does not help with sensation or lubrication.
it sounds like it would make it worse.
In many cases, it can actually make the initial symptoms worse. And this perfectly illustrates why the clinical sources state over and over again that O-shot results vary wildly based on age, tissue health, and crucially, hormone status.
It really highlights why a proper consultation has to look at holistic care. It has to look at the entire picture. You can't just offer this procedure as a quick standalone fix.
No, you really can't. A practitioner must understand this ecosystem. They are introducing a very powerful growth signal into a complex pre-existing environment.
So if the practitioner isn't exploring your underlying hormonal health, they are essentially driving blind. They have to check your biological brakes before they hit the regenerative gas.
Exactly. The ultimate success of these therapies is entirely dependent on the dialogue between the localized injection and the systemic state of the patient's body. If you ignore the hormones, you just cannot predict the tissue outcome.
Okay, so to summarize this deep dive, we set out to understand how a systemic androgen deficiency affects your tissue's response to the O shot. And the answer is that the success isn't just about the PRP being injected. It's heavily dictated by your own hormonal environment. Your body's lack of quote-unquote male hormones essentially removes the biological suppression on your fibroblasts.
The brakes are gone.
So the PRP triggers this rapid collagen synthesis, but without androgens there to act as those brakes, the repair process accelerates into fibrotic, stiff tissue instead of elastic tissue.
It completely redefines the role of testosterone in women's health. Honestly, it isn't just some hormone for libido or muscle mass. It is a fundamental regulator of tissue elasticity and functional healing.
It's mind-blowing. But before we sign off, there is one final detail from that wound healing research that feels just a massive, provocative glimpse into the future of regenerative medicine.
Oh, the Geraldo study's finding on localized application.
Yes, talk about that because that is wild.
So we know from the study that if you use a topical androgen antagonist, basically, chemically blocking the androgen receptors right at the surface of a wound, the tissue heals incredibly rapidly. But crucially, you completely avoid the side effects of changing the hormones in the person's entire systemic body.
Because it's purely localized. You're only turning the biological dial on that one specific tiny patch of tissue.
Exactly, which leads to this absolutely fascinating prospect. If we know that local androgen receptors dictate exactly the type of collagen the body builds, whether it's stiff twine or flexible rubber bands.
Could you custom tailor it?
Exactly. Could the future of regenerative medicine involve injecting that PRP payload alongside a topical hormone modulator?
Oh, wow.
Imagine a practitioner temporarily manipulating the androgen receptors in the exact microscopic area of the O shot, basically custom tailoring the precise ratio of type 1 to type 3 collagen the body decides to build.
So you're providing the massive gas pedal with the PRP while dynamically tuning the brakes at the exact site of the injection to engineer perfectly elastic tissue.
Yes.
That takes it from just a generalized injection to precision, personalized cellular engineering.
It really does. The biological mechanisms are already there, just waiting for us. We just have to learn how to speak their language.
What a provocative place to leave it. The human body really isn't just a machine with isolated parts you can swap out. It is this brilliant, interconnected chemical ecosystem. So to you listening, keep questioning those amazing connections within your own biology. Thank you for joining us, and we will see you on the next Deep Dive.